Yeah. Okay.
All right, so this is a little presentation for Math 1060. I'm just doing it by film. Um, this is Math 1060 trig. I'm just talking a little bit about my project and how it relates to things in everyday life. And one of the things I want to talk about is what's written here. It said give some examples of mass spring systems important in everyday life. Um, Describe why it would be important to understand the amplitude, period, and frequency of these systems. So you have a lot of things that people would use. The one I wrote about was car shocks. Um, if you're an engineer, like a mechanical engineer, you'd probably want to know um, what the amplitude is of the system um, that you're using to support the frame rate of a car. You want to know how it's going to act under pressure of the car. Is it going to be able to absorb the weight and help keep the car comfortable and smooth? And you'd probably use math similar to what we went over in this project. You'd want it'd probably be a little more complicated though. You'd have a little bit more physics because you'd have to account for um, pressure, air resistance, and lots of other forces at work. So I'm sure it'd be a little more complicated. Um, Another thing I thought of right now is this a slinky. Now I don't know if you'd ever really need to know the amplitude or any of those things on there, amplitude or the frequency, but you definitely could figure it out. This is a mass spring system, and you can see it starts out on this 0. We make it simple. We wouldn't have it shift up or down, and it spins at 3, goes down 6. Oops. Has an amplitude of about, it's going up and down, goes up to about 1, and then goes down to 5. It starts at 3, so 1, 2, 1, 2. So it has an amplitude of about 2. So if you put an equation, it'd be a sine x 2 or 2 sine x, and then the period. Well, that's going to be a little tricky. You might want to figure out, okay, how many revolution or how many times does it go up and down? What's the distance? Basically the same way as you do on these. Basically do the same thing. So another one. This little guy right here wants to show us that size doesn't matter. So here we go. We got this little dude. Got a little smiley face. We got his little amplitude's got 2. That amplitude is real tiny, man. That's like 0.004, 0.05. Mass spring system. Also have one more. I had it over here. Here is a little mass spring system. And what's cool about this one is you can flick it off at people. I was trying to shoot it the other day. But you can measure this one too. Has almost none. Okay. Anyways, yeah, we have this is a real simple version. I'm sure the math, I still don't have enough math even after trig to describe the motion of all these things. Probably need like calculus. But I've learned a little bit at least how it can work and some of the math behind mechanics. And so another thing you got is there's a lot of other examples. I know like a lot of buildings have shocks underneath the buildings, and I'm sure if you're an architect or something like that, you need to have how that works, how these max spring systems work. You need to know the amplitude, frequency, and period. All those things. Another thing I thought about is vibrations. The spring on a piano keyboard, there's especially if you look at the lower pitched keys, they look just like a spring. I was just looking at one of those. Pogo sticks and of course slinkies. We just went over. But that's about it. So hopefully you learned a little bit of something watching this. And it's from Math 1060, and